Hi guys, in this video, I'm gonna talk about PyCaret library. PyCaret is open source library written in Python. With PyCaret, you can do the standard task in machine learning. PyCaret is inspired by the Caret package in the R programming language. In this lesson, I'm gonna show you how to do machine learning data analysis using PyCaret. To install PyCaret, you can use pip install PyCaret command. The dataset I'm gonna use in this video is a hard dataset. Let's import the pandas to load this dataset. Import pandas spd. Next, let's load the dataset. df equals pd dot read csv. Let me set hard csv. You can find the link to this dataset in the description box below. Let's see the first rows of the dataset. df dot heat. The dataset shows the dead and non-dead cases of hurt patients according to various variables. The last column is that our target variable. The other columns are features. Now let's see the structure of the dataset. Let me zoom in. Okay, to see the structure of the dataset, let me set df.shape. The dataset has 200 rows and 16 columns. Now let's split the dataset into training and holdout. The model is built with the training data and the model is evaluated with the holdout data. I'm gonna use the sample method to split into dataset. Data equals df.sample. For 95% of the dataset, frac equals 0.95, comma. To reuse the generate data, let me set random state 0. Okay, I have created training data. Let's see the first 5 rows of this dataset. Data.heat. As you can see from the indexes, 95% of the dataset was randomly selected. Let's assign the rest of the dataset to the variable data unseen. Data underscore unseen equals df.drop data.index. Okay, we also created unseen data. Now let's reset the indexes of this dataset. Data.reset index. To save the change to the dataset, in place equals true, and let me set drop equal true. Let's see this dataset again. Data.heat. As you can see, the indexes of the dataset have been reset. Let's reset the indexes of the data unseen variable. Data unseen dot reset index. For input parameter, let me set true, and for drop parameter equals true. Okay, so we created a dataset that we're gonna use to build the model and the dataset that we're gonna use to evaluate the model. Now let's look at data preprocessing with PyCaret. Data preprocessing is done with setup function in PyCaret. With this function, you can do data preprocessing steps such as data scaling, splitting data into training and test sets, and balancing classes. Let's look at the distribution of the labels of the target variable that. Data, let me set that dot. I'm gonna use value count method. As you can see, the labels are not balanced. In the target variable, there are 131 samples of the 0 class and 59 samples of the first class. We can balance this with the random oversamplers class. Since our analysis is classification, let's import the classification module in PyCaret. From PyCaret dot classification import star symbol. Now let's import the random oversampler class to the balancing. From imp learn dot oversampling import random oversampler. The setup function is important and is used for data preprocessing. Now let's do the data preprocessing steps with the setup function. Model equals setup. Let's write our data in the data parameter. Data equals data. Let's write our target variable in the target parameter. Target equals that. Let's write true to the normalize parameter. Normalize equals true. Let's choose the normalization technique. I choose the min-max technique. Normalize method equals min-max. So all features will be in same range. Let's use the train size parameter to split into dataset. 80% of dataset be the training data. Let me set 0.8. I want to balance the target variable. Let's use the fixed balance parameter for this. Fix imbalance equals true. Let's use the random oversampler for balance. Fix imbalance method equals random oversampler. Let's use the session ID parameter to reuse the generated data. You can think of this parameter as the random state argument in scikit-learn. Let me set session ID equal 0. When we run this command, PyCharm automatically finds the type of columns. If data types in the columns are correct, you can just press enter. On the screen, you can see the operations after data processing. For example, session ID is 0, the target variable is dead, this variable is binary, label encoding none. The sample size was reduced to 190 because we balanced the target variable. Dataset don't have missing data. The number of numeric features is 9 and the number of categorical features is 6. You can see and review other definition here. There are two ways to choose a model. In the first method, you can select a particular model and then set the parameters of that model. In the second method, you can use AutoML to automatically select the best model. Let's take a look at both of these methods. I'm gonna show you the first method. Let's use the key nearest neighbor algorithm to predict whether a patient will die based on the data. Let's call this algorithm with the create model method. KNN equals create model. This method both trains the estimator and evaluates the performance of these estimators using cross-validation. Let me set KNN. Cool! We trained the model and various metrics showing the performance of the model were displayed in each fold. In last line, you can see the metric means and standard errors of all folds. Now, let's see the parameters of the model with the tune model function. Tuned underscore KNN equals tune model KNN. Beautiful. The parameter of the model was tuned. Here you can see the metric for each fold. You can see the graph of the metrics with the plot model function. For example, let's see the graph of the aug metric. Plot model. Let me set the names of model tuned KNN plot equals aug. You can see the graph of the true positive rate and the false positive rate on the screen. Now, let's see the graph of the precision recall curve. Plot model tuned KNN plot equals PR. You can see the precision and recall graph. I can say that the model is not very good. A little later, I'm gonna show you how to automatically find the best model. Now, let's predict the dataset using the model with the prediction model function. Let me set predict model tuned KNN. Okay, the data were predicted according to the model. Let me zoom out. In the last part, you can see the label and score columns. The label column shows the prediction classes and the score column shows the probability of the prediction 0. You can see the all performance of the model in the table above. I can say that the accuracy score and other metrics of the estimator are low. Let's use the compare models function to see the performance of the all models. Let me set best equal compare models. This function trains all estimators in the library and evaluates their performance using cross-validation. Let me run this command. Algorithms are trained and matrix values are returned. The yellow areas show the algorithm's best metrics. By default, the best algorithm was specified by the accuracy metric. You can use the sort parameter to find the best model based on a different metric. Random forest has the best accuracy score. We saw the performance of the estimators. Now, let's set the parameters of the best model using the tune model function. Let me set tuned underscore best equal tune underscore model best. You can see the metric of the model for each fold. Now, let's see the precision and recall graph by the best model. I'm gonna set plot underscore model tuned best plot equals PR. Beautiful. We found the best model and tuned its parameters. Now let's train the model using the old dataset, including the holdout dataset. Final best equals finalize underscore model. Let me set tuned best. Cool. We boot the final model. Let's check the performance of the final model. To do this, I'm gonna use the predict model function. Predict model final best. Here you go. You can see the metrics of the model. Now let's predict the data unseen with the final model. To do this, I'm gonna use predict model. Let me set final underscore best data equals data unseen. The model predicted data unseen. The accuracy value was 60% on the unseen data. You can see the other metrics here. Wonderful. In this video, I showed you how to analyze data using PyCaret. With the PyCaret, you can easily do machine learning steps such as data preprocessing, model selection, and parameter tuning. You can find the notebook I used in this video in the description box below. That's it. Thank you for watching. Don't forget to subscribe to our channel, turn on notifications, like the video, and leave a comment. See you in the next video. Bye for now.